Maybe I'll message you on Reddit.
Okay.
Hey guys, yeah, okay, let me yeah, brighten up the screen a bit. That's better. Yeah, okay, great. Wow, okay, you know what, let me just switch back to my regular glasses. Where the hell did I put them? Oh yeah, that's much clearer. Okay, great. Yeah, well, you know, last class and all. Well, it doesn't have to be the last class, okay? I'm very happy to talk to you next week, anytime before the exam. Just let me know. Hey, there's a bunch of us. Hopefully a bunch of you, right? Not just one person. So there's a bunch of us. We've been, getting together in a some kind of breakout room, and then we're trying to solve this. And we tried to search online, and we find conflicting answers. So could you shed some light on this? I'm more than happy, right? I can make some time and talk. Yeah, and I hope Hiram and Lay, where's Lay? Hey Agnes, you're back. Okay, good.
Hey, good morning.
Good morning. Yeah, Lay, and who was the other person? Hey Hiram, there's a couple other people last class.
I believe it was Jared Cruz.
You did share the code. Yeah, I saw that.
Yeah, I think I still have the link, so I could share it if people.
Great. Yeah, I have to confess I haven't looked at it yet, but I just want to make sure that you guys had fun and got to play around a lot with lots of different places, different things, running into different places where you needed to say, hey, oh my gosh, I wish I hadn't done that like 10 lines before. So I hope. Yeah. Hi, Madison. Welcome. So, Hiram, did you guys have fun? That's what I'm saying.
Yeah, it was pretty fun.
All right. Okay. So you didn't have fun. All right. So let's not do it that way then. What we'll do is do the usual thing. I'll walk you through some code. One of you can volunteer, drive. In fact, I think, who was it? Maddie or Madison? One of you guys said you'll take the screen. I think it was Maddie. She said she would take the screen and code up a linked list. I think it was a couple of lectures ago. Well, but it's not time yet. We usually start coding at 8:30. Yeah, so we can basically chit chat. Anything that's relevant, borderline relevant. Feel free to talk. Okay. Maybe I just interrupted you guys. Okay, you guys were having a good conversation and I interrupted you guys. So how about I just fade back into the background and you guys can talk. Unless you want to pull me in, right? So yank me in before 8:30. That's fine. I'm happy to come and talk. Or if you guys are talking and you just need clarification on something we had discussed in a previous lecture, right? Yeah, so you can yank me in. Is that okay? Until about 8:30 or a few more guys join in. Do you guys want to carry on your own conversation? Yeah, or do you just want to have some kind of a group conversation with me? I don't know. I don't care either way, right? All I'm going to be doing is just sticking around, and if you don't want me to watch the screen, I'm just going to be here looking at my notebook or just sitting by, right? Not looking at anything. So what would you like? All right, you know what? I'm just gonna. I'll be here until about 8:30. I'm not hearing anything back from you guys, so I don't know. We will start coding at 8:30, and in fact, we'll just code up a linked list without, like we talked about before, right? Without a header node, just a string of lists, a string of nodes, and then we'll try and play around with the string of nodes, do various things in it, and one of you would take the screen and drive. I don't know, maybe Agnes hasn't taken the screen for a long time, right? In fact, it was the first few lectures, and then, of course, you have constraints, right? You can't be here on Tuesdays and all.
Yeah, sorry about that.
Yeah. But Maddie, hopefully she's back, and she can drive. And because I know she wasn't well. Yeah, she got better, I think. So yeah, Hiram, just you and Lay, yeah. You guys were coding a lot last class now. So all right. So unless I hear from you, unless you ask me, or unless I hear a haunting silence. Okay, if you guys are not talking and there's absolute silence, then I'll come back, right? Otherwise, I'm just gonna leave it to you. Carry on any conversation you want. Doesn't have to be about class or C++. Just keep the airways occupied until about 8:15, 8:20, right? And if you do have a tech question, just say, hey, let's call on and back, right? And then we can talk. Is that okay? At least do a thumbs up, okay? So I know you guys are in agreement with this.
Sounds good.
All right, great, thank you. All right, only 2, but that's okay. All right, so there you go. I'm going to be here, okay? I'm not looking at you.
Wesley, I'm looking at your post on Reddit, and that's why.
This is the food.h one, right?
No, it's a string list.
String list.
Wait, oh, sorry. I made another one about food.
Yeah, I'm looking at the questing. I don't know why you're getting that problem, but I'm trying to figure it out.
But we
Are
are
you
looking
getting
at
that
the
problem
food one
too?
today, right?
Sorry, what was that?
We are looking at the food one today.
I don't know what we're doing today.
Are we? I thought he just said that he wanted to have, if possible, Maddie come and code the linked list without a header. So.
Oh, that sounds fun. Yeah, having a head node is weird.
Yeah, I think we might have run into that a bit when trying to do the linked list for the food when we were doing it in the main.
I need to review this first.
Wesley, when you did the push and push to head and push to tail, did you reuse your set prep to current method?
What do you mean by that?
Did you test out your push to head and push to tail really thoroughly?
I'm pretty sure I did. Before that test, there's 2 tests about push to head and push to tail, and I passed those. So
Okay, I don't know. That's where I have my bug. Was there, but.
Yeah. So what function was this calling in your?
advanced current.
Advanced current wasn't working. I see.
Right.
That's really
I mean,
interesting.
it's really simple. It's hard to mess
Yeah.
up. I have no idea what's going on.
Let me see.
And you checked like if the next one's null, don't advance. Like that's the only thing to check. Yeah, it looks, I don't know, it looks the same as the reference.
Right, yeah, which is what I'm confused about. I think I already have 165 trophies,
I see.
and I think there's a total of 180.
There's a total of like 195, but you only need 180 to get 100%.
Okay, so
Yeah, so you're definitely closing out.
Yeah, I just stuck with 180. I could probably go for the last, like, what is it, 15? Because I know one error that I made and I can see where the other ones are, but I don't want to.
I'm at 192 out of 195.
Ooh,
I
that's
don't
great.
know where the last 3 are, so I'm done.
Yeah, that sounds like a much better reason to just not know.
Yeah, if you're past 180, Wesley, if you don't mind, could you copy paste your code from the advanced prep into the thing?
sure.
Chat or something? I don't know. Maybe
Yeah,
not
or
chat.
share.
Maybe not chat.
Yeah, because it's YouTube. But
Yeah,
you can look at your chat screen.
it's so weird.
Yeah, it looks fine. I don't know.
Like,
Is it blocking you from like running the rest of the test? So
Yeah.
it fails. Oh no, it fails. Okay.
Wait, in the chat or on GDB or what? Online GDB?
Oh, maybe Discord. Let me go to
Oh,
Oh
Discord.
yeah, that would work.
Which did you post it?
Not yet. I'm doing
Okay.
it.
Okay, I heard it.
Okay.
Oh my god, it looks fine.
Yeah, the only difference that I even have at all is in the if statement because I used if prev to current next is null pointer, but that shouldn't change anything at all.
You shouldn't. That's not good at all. Uh-oh.
Oh no, that means that it's probably not in there and it's something different. Oh, that's
Yeah.
oh,
I
that's
don't think
awful.
it's that
It's
method.
not, it's
Yeah.
not the method. There's something more big.
What about let's just I don't know. What else could it be? Do you have any-
What could cause it? Like, let's see. What in the world could cause the test bug?
So it's comparing pointers, but data's the same.
Why does it think?
Maybe we should ask Anand too.
Yeah, we might want to. This is really weird.
Yeah.
Here's your reminder. Reopen the exams. Here's your reminder. Reopen the exams.
Wait, so it tells you that your current isn't the same as the reference. So it's doing like get current?
I have no idea. Maybe it is.
What's your get current look like? I don't know. I'm just guessing.
They're all looked at it.
That's probably totally fine.
Yeah. Another like few lines.
Yeah.
2 lines. 2 lines. Oh, wait.
Oh, okay.
Oh,
so
oh
that's
shoot, that's actually
incorrect.
it.
Oh,
That's
right, it's the
incorrect.
next one, right? But I still passed 2 of the tests for advanced current. But maybe that's it. I don't know. I'll
Yeah, so
try that.
the thing is, yeah, that's what it was for me too.
Yeah, so current
Well,
is not
I actually
present.
I used instead of returning the sentinel string, I returned head data. I don't know if you're supposed to do that.
Oh, no, that's fine too. But I think your problem is you're returning prep to current. What you should return is prep to current next, because prep to current points out the previous before current.
Yeah, I'll try that.
Okay, yeah,
I
that should
don't
fix
know
it.
if that'll fix it, but it'll at least fix your get current.
Yeah, and then you might have to modify a few other methods. But
Although
yeah,
that's
that's the
so
problem.
weird. Like if they're gonna check a method before they check the others, like shouldn't it not rely on the ones that it hasn't checked yet?
Yes. Okay, this
Definitely.
is great. Wesley, you
Yay.
can get all the points. Okay, cool.
Okay, yeah, that was it.
Oh yeah.
It passed that. Now it failed something else.
Yay!
Oh, lovely. That means that
failed
something
remedial.
worked.
Okay.
It failed
thank
what?
you. Thank you guys.
Sure.
Okay. I don't know. Maybe I'm really lucky.
You're really lucky. The first time you managed
Apparently.
it worked.
Yeah, literally.
Oh, I had a bug with one thing, but once I fixed that, it was so beautiful when it finished.
Yeah. Uh, what was something funny just happened because oh,
Well, I'm back, and because I heard some silence here. Are you guys done talking? Just let me turn it around. Hang on.
I think so. We figured out a problem Wesley was having.
Oh yeah. Okay. Cool. Great.
Yeah.
Lay. Yeah. And welcome to class. Oh, you must have joined
Yeah.
just as I was.
Yeah, I joined just as you turned the computer around.
Yeah. Great. Yeah. You have a problem. We can
Yeah.
absolutely take a look at it now.
Well, it's fixed now.
Oh, it's fixed now, is it?
Right, yeah.
Okay. So you don't have anything for me.
Right, not right now.
Okay, yeah. No, I'm not complaining. You know, as long as the dessert was enjoyed by you guys, I'm happy because I got plenty myself. Great. What would you like to do? Oh, we still have time. Yeah, we have. Let's start at 8:30, okay? Because the thing that I have in mind, it shouldn't take a great deal of time to code. Well, I suppose we could also start, coding and then digressing later. I prefer to, if we're going to do fluffy talk, not hardcore talk related to computer science, let's just get it over with sooner. And I think that's why, it's the first 20 minutes, 30 minutes, we don't talk about consequential stuff. We just, talk about whatever nonsense comes into our head. And the reason for that, I think I've told you the reason for that before. It's really just to keep the airways occupied. But, because students, like sometimes, 2 days ago, I was concerned that Hiram logged in and then I wasn't logged in, right? So there was nobody in the meeting, or maybe there was one person and there was silence. Hiram logged in and then he logged out. And then I thought maybe, oh my gosh. Maybe he came in and thought there was no class today or something like that. But that could happen to any student, especially if you have conflicting demands on your time. And so yeah. So that's why if we start coding earlier and then digress later on, then the students will come later or at a disadvantage. However, if we just do all the fluff earlier on, then when we start doing real stuff, there's a higher probability that more students will be here. That really is the reason. Okay, so let's start at 8:30. So we'll give people 10 more minutes because there are a few regulars that I'm not seeing yet. And ideally, I would very much like if Madison or Agnes could code today, right? Or, if Maddie comes back, and I hope she's better, much better. So ideally, if she comes back and takes the screen and then codes, because she wanted to do it too. I think she wanted to, and she never got an opportunity. So yeah, if otherwise, hopefully Agnes or Madison. Right? If not, I can do it too. I haven't done it for long, but yeah, it's a pain. I think you guys are set up more efficiently to code than I am, because I think I have to wear my special gloves and to my wrist will start playing out otherwise. Okay, so how about what do you want to talk about? So do you have any questions at all? You can ask me about the final. In fact, I just got a reminder. We must have set a reminder sometime during our class that the exams are supposed to be open now. Why would I open the exams now? Can someone remind me? Because the exams are supposed to be open.
I think you were saying that maybe we can take the midterm again or something like this.
And it is. So it's not open now.
I'm not quite sure. I'll check again.
Yeah, I'm on the Zoom site right now. Let me see assignments and midterm available. It says available and CS2A midterm exam. Hang on. I see. You get to see the correct answers after December 9, so that's different. Oh, okay. Obviously, I got to fix some of these before it opens because I think it says why doesn't Canvas pick up these things? You know, like, see, that's why, you know, these compilers are so good, because in Canvas I can say show the correct answers on Tuesday, but the midterm opens on Monday. No, I could do, you know, I can have the wrong orderings of some time critical things. And there should be simple things that compilers, you know, compilers have been catching things like this since ages ago, right? And Canvas is a sophisticated piece of software intended for ordinary users, not even programmers. And it should be able to do simple things like this, right? It doesn't even require complex syntax checking.
Yeah, Anand, I don't know. I don't see mine open. The midterm. So yeah.
No,
I don't know.
it is closed. It is, so I'm saying it's
Right, okay.
closed. It is closed right now. And yeah, good that I set my reminder. So, and thank you for reminding me that, you know, we can open it up, not a big deal. But before I open it up, I just, because of our conversation, I went to that page and I saw some bugs in the way that it's been set up. So, you know, if a professional software company, I think, you know, if someone like, yeah, if you went and designed this, the way you should do it is because, you know, you shouldn't have the, you know, publish or save or all these things enabled until, you know, you've done some basic checks in JavaScript, at least, right? Some dates are in the right order and things like that. And so maybe I'm just observing incorrectly. Okay, so it's quite possible that, you know, they did the right thing. So I need to take a closer look at it and see if there is in fact an issue with you know, publishing the answers beforehand, or if it is in fact done that way without a warning. I'll take a look at that. Thank you.
Also, Anand, like I would love to do the live coding today. However, to be honest, I'm quite behind in the material, and so I'm not really sure what it is that I'm writing.
Yeah. No, you don't have to. You don't have to. What we'll do
Yeah,
is
I would love to,
you
but I
actually, you
feel
know what,
like
Agnes, thank you for bringing that up.
yeah, I'm
Because
sorry to confess, but I feel like it'll pull everybody behind because I clearly don't know what I'm doing.
okay, all right,
and
it's okay.
I'm
If
sorry
you're not
about that.
comfortable, it's perfectly fine. You just have to say yes or no, right? Because you may not feel comfortable for doing this for a million reasons, right? And so you don't have, you don't have to disclose the reason to anyone. You're not obliged. And you say I'm not okay with coding today, and that's perfectly fine, right?
I don't want everybody to
believe,
be like, no,
however,
that's 2 equals there or anything like, you know, very
however,
fundamental.
yeah. I don't believe, however, that you would have held up anyone. Okay, no matter what speed you are coding, we will code at your speed, essentially, right? Because as we've already demonstrated time and time again, we are Murphy's Law in action, meaning that we can take a very, very simple thing and we can make it last for 10 minutes by just filling it with lots and lots of fluff and digressions. Yes, so so the smallest amount of work can occupy the greatest amount of time. You know, given the, you know, so we can absolutely do that. So nobody will ever hold anybody up, right? So at the end of the day, we just want to end this class with a with a feeling that it's been worthwhile, right? Even if you didn't actually learn anything new, maybe you came in already knowing most of these things, and, you know, just syntax changes from one language to another, and you just needed that check mark on your transcript or something like that. That's fine, okay? But still, I paid $170 or something for this, or a certain amount of time in my life, right? Because, you know, people these days go to YouTube and say, you know, I watched this video, I want those 5 minutes back, right? So I wasted 5 minutes of my life on your video, give me those 5 minutes, right? So people are trying to measure these things now. So people are in fact coming to these classes and sitting through them, and even though they may actually know much of this, right? So we have to make sure that, you know, otherwise there's no point for either for you or for me to have this class. Right? I might as well write a book, and you could buy it if you're bored and so inclined to read it. So the whole point of this class is to have fun, right? And when I stop having fun, and you stop having fun, and that's probably when we'll say, okay, that's we've had a good run. Okay, so then, you know, you can retire and do something else too. And so yeah, we just want to have fun, and along the way, I'm happy that, you know, we had an opportunity to cover every single thing that the syllabus required us to. and I found it worked better for me, and I think for you, because I can never be certain, that this way of introducing concepts sprinkles throughout many little projects, right? Rather than doing them in some prescribed sequence, right? So first few weeks, we're going to talk about constructors and structures, and then this is methods, this and as a sequence, which may not has worked better for me, because now what we've done is we've just taken lots and lots of projects. Some concepts will be covered multiple times because they're more common, right? And some concepts will be covered fewer times. But in the end, we would have essentially covered all concepts, right? But the less important ones would have been covered less, just by virtue of us working on multiple projects and the overlaps due to the real world interactions. So I think that has worked better for us. And if you don't think so, you can just send me a private message at any time saying, maybe, this might have helped me. And if I get a lot of those messages, then, I can basically just say, hey, you know what, we should try this other way, which might give us greater success rate, right? With the students. So yeah, so absolutely, we can try and do that. In fact, Kofi, I don't know if you're doing one of his courses. I think he teaches. I thought he taught Java, but I think he teaches JavaScript or web or something like that, because he's also championing some web development certificate. Because I'm in the curriculum committee, right? So, so yeah, he just sent me an email. I think so. He wants to talk about student success and see if we can do something, or wants to. Yeah, maybe it's a department meeting, right? We want to call a department meeting. This is the right time of year, I think, to look at to see if students actually benefited. And then informally, at least, talk about stuff we've heard back from students, and say, if we did this, maybe, maybe more people will learn the interesting and cool things. I think the goal of any department, any division, really, during the A-level courses is to get you fired up enough, right? Interested enough and fired up enough so that you'll continue on. I mean, that's not my explicit goal with 2A, obviously, right? My explicit goal is not to basically say, I want this to act as a funnel. I've mentioned this before, into 2B and 2C, so that we get a lot of students sampling 2A, but the ones that are interested will go on to 2B and then 2C. It's a good side effect, though, that we have a bunch of students who will take 2A and go on to 2B and 2C, but every department is trying to maximize that, I think, right? So any department you go to, and they want to get you jazzed up enough. And that's why I've mentioned this before. Even if you go to universities that are research focused, in my experience, the higher level courses sometimes get taught by TAs, research assistants, postdocs, but they take great care that the intro courses are taught by the seasoned profs who've seen many generations of students. Yeah, right, because they want to make sure that enough of the first years are inspired enough by the subject to carry on and sample the real goodies down the track, right, which we have to offer. So that's the goal of every department. And I think it's the same for computer science, and maybe we'll talk more about this, right, because we'll get the program review opportunity and so on. But anyway, that's what it is. We can start coding. And so I recognize it, Agnes. So say, yeah, it's fine. You don't have to code. And Madison too, I know. Well, which pretty much leaves either Hiram doesn't want to code. Either Alexandria can take the screen, or Lay, or what I can do is I can, let's see. Well, if Alexandria doesn't want to take the screen and code, I can try and code to I don't know, to see what, or if you don't want to code, that's also fine, okay? Because, you know, we're coding every class, but if you just want to talk about questions, you know, talk about questions and figures for linked lists and what we want to do. Or if you want to talk about the midterm, the final, data representation, anything to do with C++, finals, that's also fine with me, okay? So you tell me what you want to do. Either one of you can take the screen and code.
I can code today.
Yeah, okay. Thank you, Alex. I appreciate that. Yeah, I was also ready to code. It's not a big deal for me, but you know, it's better for me if you code.
We haven't seen you code, so that could.
I know. Yeah, I can. Yeah, you want to? There's a whole bunch of videos on YouTube, right? When I've coded, and the whole class was basically me coding, and it's basically a bit of a pain, really, right? I mean, I talk about it too when I'm coding, but mostly, you know, it's basically, I think if you go to the early lectures, face-to-face classes, in fact, it's strangely enough, they're face-to-face classes and I'm coding. So it's the face-to-face classes, and there's my desk and my laptop on it, and I'm basically talking about linked lists or hash tables or whatever it is, and I'm coding it, and my screen is projected to, and I'm talking about that. And that I don't know, that never worked for me, right? Because I'm coding and I don't know if people were even following me. And because, you know, sometimes I walk around and, you know, people are watching YouTube in the back. I'm not saying that's what's gonna happen, but I can absolutely code, right? So we just have to pick a topic and then we can code today. Anytime if Alex is tired and says, you know, hey, can you just pick up and code? I can just pick up just like another student, right? I should be able to pick up just like a Hiram or someone, right? So with that link, I should be able to pick it up and start coding there too. Yes. I mean, last class, if I'm not mistaken, all three of you were coding in the same window, right?
Oh, yeah.
Not you, Alex. Hiram and Lay and someone else. 3 or 4 of you, because I mean, I couldn't see your screen. You weren't sharing your screen, but you were sharing your camera. So I only see the 3 of you from time to time when I peek, but I never saw the screen.
Right, we were using Replit.
So yeah, fine, Alexandria, you can just continue doing what you're doing, right? Anytime you want me to code, just, you know, we can just transfer over to a plate and then we can do that. Or if you just want to continue on to the end of class, that's fine too. We can talk about stuff, and that's great. All right, so yeah. All right, so let's do a very quick linked list. Yeah, great. Okay, fantastic. All right, and what? How do I get the link? I'm not going to code right now. Okay, so in fact, what we'll do is, you know, we'll see how it works. Okay, at some point, you can tell me do this while I do that, and I can. How do I get to edit this, Alexandria? Oh, this link. So do you actually copy and paste that in chat or something? How do people do that in class? Invite. Okay. How do you do? Oh, okay. Then you can. All right. So you can paste that in chat, and then I can join through that. Oh, you have to get out of camera mode. It's a share screen mode to this. I see. Funny.
I'm not sure, but that worked.
Yeah, it worked. It absolutely worked. Okay, so I'm actually in it, and oh, it asked me to log into my account. Oh wait, I thought Hiram said there was a way to share it. Oh, all 3 of you had accounts. So all right, why don't I log in? Oh, geez, it's sending me this MFA thing to my phone, and I don't have my phone here with me, so I can't log in unless you give me some time. Not time. Yeah, so yeah, I use Google to log in. Maybe I shouldn't use Google to log in. Maybe it's an option to join with email or something. All right, so I don't have to do. Yeah, I'm signed out of everything right now because I had to reboot my machine, and then so I was going to do MFA for every single thing now. Hey, Alex, why don't we just continue with you? And then, so sorry, I'll try and see, in the middle, if I get an opportunity, we'll try and log in and we'll find a way for me to code also. Hopefully it'll be fun. Okay, is that okay for now? Why don't you just code and then we'll see if I can do this.
Okay.
Thanks. All right. Okay, so let's say, let's clear this and start with an empty slate. And then we'll create an empty, and then let's create a node structure that is just linked. So basically we'll have a node and then let's put a number in it. Okay, node with an integer and a next pointer to a node star, right? Next pointer to a node, which is a node star next, right? So so your basic node, right? So let's, yeah, you can do it right there. You want to do it make a class? That's great. Okay, yeah, that's fine. So so what Alexandria is doing here, by the way, I don't know if we've used this notation before. A struct is simply a class. You can, for all practical purposes, right? A struct is a class in which everything is public by default, right? You can do it, pretty much you do everything you can do in a class, you can do inside of a struct. Although, I hate Alexandria, I'm very puzzled. I'm very curious. I've never done this in the past. What happens if you put a private inside a struct? Try that. Let's compile it and see what happens. Just say private colon and say I right there, and then let's declare a struct node. That's in it. That's it, right? In main, let's just do a struct node and compile it and see what happens there. Yeah, triple click the line and get rid of the hello world and say, struct node right there. Yeah, triple click the line, yeah, and say struct node.
Put it in here?
Yeah, and well, I'll say node in lowercase maybe, and a semicolon. All right, so let's see if get rid of the comment. Wait, when do we return 0? Who put the comment?
Yeah.
Did Replete put the comment there?
No, we were wondering. You don't have to put 0.
Oh, I see. So with that, we put the comment there, but I thought you just opened up the window and was that,
I think Wesley put it.
Sorry, that was me.
Oh, I see. Okay, cool. All right, so it looks like multiple people have access to this document except me. All right, okay. So yeah, this is funny, isn't it? Because this return thing from main is a very curious thing, isn't it? If you want, I can talk about it, right? It'll take about 2 minutes. It'll take about three minutes. I can talk about it, but it's actually very interesting. It's an interesting thing that some main is a function that returns something. Why not have a void main, right? In Java, if you, what's the signature for main in Java? Is it void? Static void? Or static in?
Returns, I think it returns.
I think it's static void.
I thought it was void too.
Yeah, it's void.
Yeah. So in many languages, the main is void, isn't it? It doesn't return anything. But in C and C++, the main actually returns a value, right? And it actually returns an integer. And also the further thing, if the more curious thing about this, and I actually made a point about this in quest number 1, right? In the Tiger quest, there's a question in the spec. It says, hey, main returns a value, and it's actually counterintuitive, right? Because in C and C++, 0 is the same as false, right? False, the Boolean value false in C++ doesn't actually exist, right? There's no concept of Booleans in C++, right? So what you have is syntactic sugar, meaning I'll give you something called false, but the compiler is secretly going to replace that with the value 0, right? And true will be replaced by 1, but technically in C and C++, a 0 stands for false and non-zero, not empty, right? Anything other than 0 stands for true. So, and it's been exploited ad nauseum, right? So that fact that you can have that is a very nice feature in C++. So many people in C and C++, or people who are used to C and C++, when they write while loops, they want, when they say while n minus greater than 0. I don't know, can I use that expression in vocally, like, instead of typing it out? Or maybe Alexander can type it out just to, show what I mean. So you can say, hey, in main Alexandria, for example, can you say while you put a comment there saying some random thing just to illustrate a point, not connected with the code, right? So we can erase this later, right? So some people say while inside of the while loop, right? So inside brackets, say while n minus greater than 0, do something inside the loop, right? So you can have some, and inside the loop, so n minus, so that's a common way of writing this, right? So that's what Java programmers and other language programmers would do, where you have an integer variable, integer or size t variable or integer variable, right? And it's keep on decrementing it inside the loop. And while it's so, but what C programmers sometimes do is will actually say, you know what, it's going to decrement it, which is 1 machine cycle. Really, decrementing is 1 machine cycle. Really, it will not be it's 1 instruction, right? It may not be 1 machine cycle. Obviously, I shouldn't be saying machine cycle, right? That's actually an error. So it's 1 instruction, because decrement is at the assembly level. It's just 1 instruction, right? Even at the machine, at the instruction code level, not even assembly, right? Instruction code, because most most architectures come with an instruction. This is increment or decrement, right? So it'll be, so that is 1. So when you have n minus minus greater than 0 at the instruction code level, most programmers will imagine that it's really cheap, because you only have to do that 1 instruction to decrement, and then 1 other instruction to compare. Because also there's another instruction for compare this value in the accumulator, which has just been decremented, with this other value, which is a 0. So that's also one, because there's an if jump, right? So it's a very cheap. That's a very cheap construct. But what C programmers would do would say, I want to go even cheaper than that, because in C++, I'm going to exploit the fact that 0 is false and non-zero is true. So what they would do is say, get rid of the greater than 0, and they'll say while n minus minus. That's it. Okay, and that means that as the integer, you keep on decrementing. When it becomes 0, it's false, and it gets out of the loop, right? So it's so cool, isn't it? So you can so these are things that people exploit, and so you say that 0 is false and non-zero is true. Everything non-zero is true. So when it comes to returning the value, every function returns a value, right? So you can either have void, meaning it's a pure procedure, right? It's a complete pure procedure. There's absolutely nothing to return. It doesn't make sense to return anything, right? It's like, pop, for example, right? Guaranteed pop or something like that. So you can say it's void. However, if you want to return something and say, well, I did something and here's a value that indicates something, that's a return value. Now, you can have 2 kinds of return values, either, success, failure, like Booleans, right? It's true or false. Is it true? Is it false? So you can either have 1 or 0. 1 or you can have 0 or non-zero, true or false, right? This is in C++ jargon. Or you can say, it could either succeed. If it succeeds, no problem, right? Success is what we expect. No explanation needed for success, right? And that is how humans think, right? As humans, we think if we succeed, yeah, obviously I got to succeed because I'm a brilliant guy. I'm intelligent. I'm a cool dude. I got to succeed. But if I fail, we always look for reasons, saying, why did I fail? Right? Why did I fail? Because, there's no reason I should fail. So if I fail, there's got to be these problems, right? So we go do a postmortem analysis and try and look for failure. But, we should have the same level of analysis, analytical mind, even if we succeed. And then we'll see that, success is nothing special that was given to us just because of, our intelligence. But, it's equally likely, not equally likely, but, we can chart things out more sensibly, right? So, and I think, so you can say, a success, no, we don't need to explain anything, 0, right? Or, true. But, or failure, now we have to explain a whole lot of things. Right? So maybe it failed because of a file not being found. Maybe it failed because the CPU, did something weird. Alpha particle hit it from a cosmic ray, right? So a whole lot of reasons. It's a memory failure. So if it's a failure, I have many cases to explain. If it's a success, no explanation needed. Okay. So if we start from that mental paradigm, right? If we say, let's subscribe to that viewpoint, that perspective that says the success is to be expected, which means no news is good news, right? That is the underlying philosophy behind the design of many things, right? Many incredible things, including the Unix operating system, right? Because it is a standard slogan in the Unix lab, in the Bell Labs, where Unix was born, right? AT&T Bell Labs at the time, I think. No news is good news, meaning that if everything is fine, don't bother me because I'm having a good time, you're having a good time, everything is fine, no need to bother each other. Okay, so let's just have a good time, right? But if something is wrong, then you got to speak up, right? The same case with students too, right? If you're silent, I'm just going to assume that you're having a good time and you're getting interesting stuff out of it, right? But if you're not interested in the subject matter, if you're, or if I'm saying something wrong and you need to correct me, hopefully there's plenty of opportunities to do that, right? So I expect that you should basically speak up and say, no, that's not right, right? Wave your hands or something like that. Because that is the way I would know. So no news, it means good news, meaning that everything I say, you guys are agreeing with, or, at least you say, I just look in that direction, okay? Because maybe, it's on YouTube, I'll watch it later and then I can disagree or agree later. That's also perfectly fine, right? So as long as we're not distracting other students, that's fine. But I would really like it. When I say wrong things, you should basically say, hey, doesn't make sense to me. You don't have to. So if you feel, many students may feel, well, it doesn't make, it's not polite to correct professors, right? So you got to say, if you disagree with them, disagree silently, right? But that is actually an insult to professors, right? Or at least to me. So if you disagree, you should just say, that doesn't make sense to me. So maybe if you feel uncomfortable saying it's wrong, you could say, hey, Anand, it doesn't make sense to me. Right? So that's perfectly fine, right? There is absolutely no professor on earth that would be offended when you go to them and say, what you said doesn't make sense to me, right? So you're never saying that you're wrong. You're saying it doesn't make sense to me. I can't understand what you're saying, right? So it's then the onus is on the professor to basically explain it in better ways or try and explain it from your perspective, which maybe he or she might have completely missed. So I don't know where we're going with that, but yeah, return values. We're talking about return values. This is well past 3 minutes. I'm so sorry. Okay, so but it's good, right? It's just front loading before we start coding. So return value is now when we come to, so main is a function, right? Now main is a special function. Now main calls other functions. That's the entry point, right? So every function you write is got to be called eventually by some function that is called by main. Yes. It's either called by main by itself or it's called by some other function that's called by main, right? So, but who calls main? So you as a user go to the operating system and either type it into the command line in DOS or Windows or Unix or something like that, or you're going to double click an icon and get the GUI to actually do the equivalent of typing it in. It's going to fire up that. So you're going to initiate it, but how does the CPU know? It has to start executing. So there is an understanding that when the program is loaded from the bytes, the instruction set on disk into memory, right? The operating system, which takes it from the disk and loads into memory, is now going to signal the CPU. So it's going to put some values in certain places in memory, right? And it's going to signal the CPU saying, now I have loaded a program up for you to run. And here is the instruction set. Here is the instruction that you have to execute at, very first, as soon as I say go, right? As soon as the, pistol and in that running race is the races, right? As soon as they say go, right? You got to start. And this is your first instruction. That the address where it has loaded the very first instruction, that is the only thing that main gives to the CPU. Well, there's other metadata, obviously, right? So, but that's all the CPU really needs, because from that point onwards, it will start executing instruction by instruction, right? And one after another, sequentially in memory, as main has taken from disk and put it into memory, right? And then told the CPU, I put it in memory there, you go and execute it right there. So there is technically nothing to prevent main or have a theoretical CPU that doesn't require memory. Right? The CPU, in theory, could just basically equally well operate off a hard disk. Yes or no? Right? Technically, it'll take millions of years to do something very simple. Right? Well, maybe not millions of years, but technically it operates off a hard disk too. Yes? Okay. Now, if it could happen off a hard disk, right? It could also happen on a notebook. Right? The notebook may be really, really big. Yeah, huge. Yes. So it could also happen in a notebook. So you can take that notebook and also strip it, tear it up into pieces of, strips of paper where, each line on the notebook is a separate line, right? So you can have one long strip, one long tape on which your program has been sprawled, right? In bits, right? Dots and space, dots and dashes, right? That's the same, right? They're all, it may stretch from here all the way to Jupiter, right? Ones and zeros, but it's still the same. It's the same program. So it's there in memory, and none of that is needed by the CPU. That's the beauty, right? So all the CPU needs is just to be told that here for the instruction set you're working on, here is the very first byte that you need to look at, right? And from then on, the CPU basically takes over, because that byte, after executing that, it's going to look at the next one, increment. So it's got what is called, I think is it called a program counter or instruction pointer? I don't know, right? You got to check with people who are doing, computer architecture, right? I think it's CS10. We offer that too, right? So, so that program counter, instruction pointer, that is a place where main will load the instruction corresponding to the very first statement that will eventually lead into main in your program, right? So main is a function. Now someone calls main and the operating system calls main. Okay, so that this extremely long story leading to the place where main is being called by the operating system, right? So by you typing into shell, right, the GUI or something, and then going through the operating system, and the main basically takes that program, loads it to memory, tells the CPU go to memory and take that first instruction, start executing from there, right? And it's going to keep on doing that until it encounters a situation where it says you're done, return, right? The CPU will keep on doing that, stepping through one at a time, right? And it's doing it so fast that it can go through that really fast because it's in memory. But anyway, so when it gets to the end, main is being called by the operating system. And what happens? So the beauty is that when I think it was Unix, right, or some precursor to Unix, right? So when a program was run, people realized very soon that individual programs can do really cool things, but even cooler things can be done by putting these individual programs together, not mixing with each other, but you doing your job and you doing your job, but this guy taking the output of this guy and giving it to the input of this guy and taking the output of that guy. So, right, mixing things together, not mixing things, juggling these things together, right? So they thought, right, if we want to do, let's say, a join of two, let's say join is a classic operation, right? I don't know if people are, do you know what a join is? Join of two structured data sets. Suppose you have, let's say, students, right? So you have student name and student ID, right? Student ID, student name, and it's sorted by student ID, yes? Another place, I have student ID followed by the grade, right? Two different Excel tables, two different Google Sheets, right? So student ID followed by grade, student ID followed by, I don't know, name, right? And someone says, what is the grade got by this student name, right? I got a, what is it? Yeah, right. So I got to map this name to that ID. Whatever, right? So you got to go. The common field is the ID, which is, sorted. So if they're sorted, it's really cool for me. I don't need a hash table to look things up. I can basically just walk along the two like a zipper, right? And then if they're sorted, right? I think you may have a. Unfortunately, it's not a quest. Okay, but there is actually a spec sheet that I wrote maybe 6 years ago, along with the intersect on my old homepage, right? If you go to programming challenges, where you have two sorted lists and you have to join them in linear time, right? So it's a fun exercise, right? Two sorted lists and you have, maybe you can do that today, right? That's actually a really cool exercise, right? So we have two lists, right? Both of them are sorted. And then you have to join them such that the resultant is also a sorted list, okay? And that's a really fun exercise to do, right? Because you have to do it like a zipper, right? So you have to walk the lists and say, and that's going to be fun for you to do. Is that a fun thing? Can we do that today? We'll finish the main conversation, but that's something we can do today, right? Yeah, Alex, is that okay? Great, okay, fantastic. So you guys can
merge sort?
Sorry?
It sounds like merge sort.
Yeah, it's exactly like merge sort. Yeah, okay. But let's not use technical terms, right? So let's just say we're just going to take two sorted lists, right? And we'll just mix the two, right? All right, and maybe if you continue on to do CS2C, and then in quest number 7, you got to do some sorting things and say, oh wow, I got to do something that I actually already did in CS2A, right? Okay, CS2C in quest number 6, that'll be fun. Okay, so and that is actually the hardest quest, believe it or not. This is fewest number of lines, quest number 6 or 7, according to students anyway. So I thought it'll be one of the easiest, but it turns out it's one of the hardest quests of the entire series, right? Of all of the 27 quests. Shark. 7, CS2C, 7th quest of I thought it'd be the easiest. Fewer than about 50 lines of code, but it's actually one of the hardest according to the students. Right, so everybody says I got devoured by the shark. But actually the shark is a friend, right? So I was watching a YouTube video or Facebook video of this woman who actually just goes as a scuba diver, right? She goes to the bottom of the ocean and she just sits there, and all these, ferocious looking sharks, they just come and then lie down next to her like a puppy, right? And then she pats them, and then she removes the hook from their mouth. And then the shark nuzzles with her and it goes away, and then a few more sharks come, okay, and they're all hanging around her, waiting for the turn, so that she goes and pats them on their back and removes the hook from their mouth, right? And then they're playing around with her and go away. So incredible, isn't it? Fantastic. And that's what she does all her life. Not all her life, but all her time now. And it's a very nice video, right? I think it's taught, the video is shot like IMAX style and things like that. Even though it's a YouTube video, I think, or YouTube or Facebook video, it's shot in a very nice way. Extreme clarity and very nice. It's nice. It's like one of those David Attenborough things that you see on BBC, right? For a long time ago, when this thing was new, right? It's really. Anyway, what was I saying? Yeah. Okay. So main return of value from main. So the operating system calls this, right? And this function main runs and returns. So when people said, right, so when I build things in using lots and lots of C++ programs, right, program A, program B, program C, program D, each one is really good, right? Sort, and this one is a join. Join is basically taking two sorted things and doing some funny things, right? Like the ID that I talked about, joining two things, right? And in linear time. So the algorithm we're going to implement today, in fact, right? Okay, so it's I have a sort program, I have a join program, I have a unique program, which will basically just get rid of unique duplicates and things. So different things, right? I don't have one program which does everything, which is a real mess, right? Because that's our temptation, right? We all want to write very general purpose programs that will do a whole lot of different things. But if we say no, let's not do be a jack of all trades, but we'll do each thing, we'll do a lot of things, but each one should be self-contained and separate. So we have a sort, which does really, really good sorting, right? Many different ways, but just sorting, nothing more, right? Join, and so they built all these things, and they said, and then people got really good at just throwing them together without cutting any C++ code themselves. And there were so many interesting problems we solved just by taking existing programs and then chaining them together in interesting ways, just like Lego, right? So after you built all the building blocks, putting them together was a great deal of fun. But then people start thinking that, if these programs, well, all of this happened before they even created the very first one, obviously, right? But I'm talking the hypothetical world. So I was thinking that if this program produces output that this program needs, then this whole project with 100 different invocations should all not continue if this program failed. Right? So programs should have some way of signaling to other people if they succeeded or not. And more importantly, they should also have the ability to signal to other people if they failed in one of, let's say, 200 ways, which the other program can actually handle. Meaning that, sort failed because of the absence of one file, right? When it was asked to sort 100 files, right? So maybe it doesn't exit with a saying complete failure. Maybe it says, it failed with an exit code of something, something 23, right? 23 means it failed with one file. So can you still proceed with, with a likelihood of success rather than things like that. So decisions can be made, right? In some complex chain. Like recently, for example, Amazon, I think recently released was machine learning is being commoditized, right? Everybody can use machine learning now. So like Unreal did with programming too, right? Taking everything visual. So I think if Amazon, all the other companies are going to follow suit, or maybe they've done it too, and I don't know, right? But this is new. What is in the news is that they've basically taken the machine learning building blocks and they put them up as black boxes, which people don't have to dive into. I don't need to know the details of naive Bayes and the theory behind why naive Bayes works in a data set in which probabilistic decisions can be made. But I know that in this data set, naive Bayes works, so I don't need to know the math of it or even the C++ of it. I just take the naive Bayes box from a Google or Amazon and plug it there in on my on my canvas with grid, put it there, and then I put my data set here, right, and then I wire it up with my mouse, and I say here's where my input is coming from, and the input is coming from some log file that's been preprocessed by some standard preprocessing stuff that you can also get for free, right, or free for or as a resource. So you plug all these, and the thing is you're not doing any C++ coding, yes. Right, but you're actually using a lot of C++ here. because each one of those blocks has been optimized to take, and the thing is to see exactly the same way. We start off writing programs, and then these come together, and then we start talking about, different higher level units talking to each other. Higher level units talking to each other, they need to have some way of signaling, right? So the way of signaling between main and the operating system. Okay, now we're coming back to saying, how do I put these things together, right? So I need to know how this thing failed. If it failed, I need to know how it failed. But if, that's main, the operating system calling main, and main telling the operating system I failed, right? But this guy needs to know, okay, well, he failed. Not only do I need to know how whether he succeeded or not, but I need to know if he failed, how he failed. Right, so the operating system needs to tell the guy, so, well, it's not 0, which means he succeeded. But fail could be one of 255 possible reasons, and maybe you can handle 1 or 2 of those reasons. Right? But here's the code. Do you understand? But in order to be able to do that, to assume the paradigm that success needs no explanation, but failure does. Right. So we have to assume that is our framework. If we approach it in that way, we say, we will use the intuitive opposite of what C++ uses for true and false for main return values. Right? People don't talk, we don't think about it, right? But that's what we do. In main, when we say to the operating system, return 0, it means nothing to report, sir. Okay? No news is good news. However, if something went wrong, then I'm going to give you some news. I'm going to say, well, it failed not because of me, but because of Joe here, who was absent on Thanksgiving Day when we had a release, right? So you can actually point fingers. You can point fingers at 255 different people and say it failed because of that, right? Not me. And that's the reason why main has to invert true and false in order to return values to the operating system. Does it make sense? How long did we spend talking about it? Not 3 minutes, obviously, right? So a lot more than 3 minutes. But I hope it was useful. Was it useful? This I don't know. Maybe most of you know this already, right? But not useful. I hope it was entertaining, because maybe not all of it was even true. Because most of the time we're talking about why the motivation and saying, oh, we did this and we thought we got a problem, we solved it. Because what usually happens is that all of that has taken place really in the mental world of these programmers, right? So it's not like they did it and then they went back and said, okay, now we got to make this return values. When you write this program, right? Eventually, I'm going to have to link this thing together and bam, 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 right? So even the very first iteration may have taken the form of main returning 0 and inverted values, right? Because most of the reasonings that we spent like 20 minutes talking about might have happened in 20 milliseconds in someone's brain too, right? So, and that's also, one of the reasons why some of these things are, counterintuitive. But people don't, that's the thing, right? People don't pause to think about things that are counterintuitive if we've been used to it long enough. Yes, and I think that's interesting, isn't it? And I think I've made this point before, even when we talk about data representation. I think I've made this, because the way we write numbers, if you think about it, for English speakers, for speakers of some family of languages that are right to left, right? So we made it, for some languages are top to bottom, some languages are left to right, and some languages are right to left. Right? Arabic, for example, is right to left. Yes. Because I think there's a very interesting story about the Tide detergent, right? They had a campaign with only 2 boxes where, dirty clothes on the left and clean clothes on the right. The sales took off in New York, and they ran the same campaign in Dubai, and Tide basically tanked because everybody was reading it the other way, right? So right to left, right, left to right, says big endian, little endian, right? So that's the whole thing about byte ordering. Where did we start talking about byte ordering? Where did we start talking about that? Hang on. I'm sorry, I lost my train of thought. Anyway, it was fun, right? So I think the point I was trying to make was that it's fun. Some of this just people just when you write programs, you just make decisions and it just sticks around. Counterintuitive things, right? Yeah, but data representation. Other things is the numbers, the way we write numbers, left to right is counterintuitive. How many people have paused to think about that, right? It's not the way we write English, right? It's the way we write English left to right, right? So, and numbers also left to right, you can say, oh, it doesn't look it's actually counterintuitive, because if you think about it, as a number becomes bigger, the increasing powers of 10 are put on the right side. So you start with 1, right? Increasing powers of 10 are put on the left side, not on the right side, right? So as a number grows, it doesn't grow to the right, it grows to the left. The left side has increasing powers of 10. And that's counterintuitive because in English we're used to writing on the right. So but actually, if you're a linguist and you're interested in thinking about these things, there is actually very strong evidence that a very long time ago, if you go back to the ancient inscriptions in India, the stone cuttings and all, you see numbers actually written in reverse to what we're used to now. Right, so pi, for example, was 3,1,3,1,4,1 this way. Numbers basically, and I think it is because that is the natural way in which people who use languages that are left to right would also write numbers. But sometime along the way, it got reversed, and it became counterintuitive to speakers of a language which went the other way. And I think the theory that is currently accepted is that it's because the number system went to the Middle East first. Right, and through the Middle East to the West, right, and in the Middle East things had to get reversed, like the tide ad, right, in order to make sense. So the numbers also got written the other way, and then what we today refer to the Arabic numerals or the Hindu Arabic numerals originally were actually written in increasing powers of 10 on this side, not on this side. So which agrees more with our notions of language and how for many people that write from. So, but I don't know if you went to if you were talking to a people whose language went from top to bottom, their numeral system might be different, right? Because I mean, they also may have from top to bottom, bottom to top, maybe 3-dimensional numbers. But you can also think about 4-dimensional numbers, right? So people, you can have civilizations. We're talking about numbers which span 4 dimensions, and the structure of numbers.
Japanese goes from top to bottom.
Top to bottom.
To
yeah. See, yeah. So then,
and so we have entirely different.
But still, right? So the thing is, you don't have to spend more than I think you don't have to spend more than a couple of months in that system before that starts becoming feeling natural, right? Or if you were doing that and then you came to this way of representing numbers, I don't think it takes a couple. How long does it take? Because I don't know, maybe
I'm sure it's not that bad. But my mom, she could she was an abacus teacher.
Mm-hmm.
And that's just, I don't know, that's just some black magic for me. She can do some ridiculously huge numbers in her head.
Yeah. So because many of these algorithms, it's basically an algorithm, right? I mean, today we look at, let's say, quicksort, and we're, it looks a little puzzling to us how it works. But once you master quicksort, you don't think about it so much, right? So as you say, you use quicksort, you're going to say, right? You get this value. Even if you go to Wikipedia or something and look at the animation in JavaScript, something like that is running, right? So like that, and abacus, they're incredibly complicated algorithms. I know, I've seen people, I don't know how to drive it, but I've seen people, some experts drive the abacus. I'm pretty sure there's lots of videos on YouTube also, right? And your mom might be one of those, right? Especially if she was a teacher and all, right? So she may know many complicated algorithms that, you have to have years of practice to make sense of. I'm sure if you ask her to prove it, that it actually works, you can basically lay down a painstaking for us, step-by-step proof, tracing all the way back to, one beat movement and saying, okay, if this works, everything else works. Yes?
Probably, but
yeah, I'm very sure
she tried to teach me and it just never worked. So that's
because it's not because I don't. This is my opinion. I don't think it's because today's generation lack a certain skill set or knowledge that a previous generation had. It's just that it's like evolution, right? So it's a different set of skills is necessary for adapting to today's world. So we basically just shift, right? If you had to immerse yourself in that other world for a few years, I'm pretty sure, right? There are people who've been switched worlds completely, and after a year they just become completely acclimatized, right? So I think that I don't think that mankind is getting any wiser as we go or has been dumber in the past. Most of the time, I think there have been bright people and not bright and not to say put values on it, but people who are interested in certain things and people that are not interested in other things. So all through every age, right? Yes. I don't know. Again, things are you can check these things out yourself. But yeah, abacus. I continue to be mystified by many of these things that are not at all obvious, right? Like you say, Agnes, it's like magic, isn't it?
To me.
Yeah, it's like Yeah, even quicksort is like magic for many people, right? But I'm saying this, the really complex algorithms, right? That will be like magic, like you do on the abacus. Yeah, so I'm saying that I don't think any less intelligence than any less intelligence has gone into developing some of these techniques in the past millennia. Then oh, that's my hang on just a sec, okay. Oh, one sec, okay. பண்ணி கிளாஸ் நடந்துட்டு இருக்கு இன்னொரு 10 minutes பேசலாமே கிளாஸ் நடந்துட்டு இருக்கு so yeah, what was I saying? Yeah, abacus, and it's a millennia, right? So people have been thinking about, just because they haven't been thinking about things using our language or our paradigms of thinking about it, or computing or bits and bytes, it doesn't mean they were thinking about less sophisticated or less difficult things, right? I think people were thinking about difficult things for ages, and they were coming up with about the same rate among humanity of brilliant answers. I don't think it has improved. We just may continue to make progress in different levels. That's all, I think. But the fundamental problems, I think the rate of emergence of solutions has pretty much been the same rate for millennia. And I think the same amount of intellectual output has been happening for millennia too, right? Maybe just not in forms that people want to see, right? Because it's possible that we're accustomed to certain things, and so we only look for certain things in certain ways. Or maybe we don't want to see certain things and we don't see them too, and we can still live a comfortable life. That's also possible, right? So, but it's not realistic to expect that ancient cultures were any less intelligent than us. So I think important problems have been solved all along at the same rate. We just like attaching name and form and power and glory to humans. So we do that in the current age. But I don't think that's always been the norm, right? So many brilliant people have done brilliant things, equal, comparable, or better even than some of the best names we know today. And they're purely anonymous, practically for us anyway, for all practical purposes. So yeah, talking about the abacus. So yeah, it's kind of fun. So yeah, to cut to the point, the point is that I think that there are these brilliant things that even ancient cultures and civilizations. Anything else? We're starting to do this, right? This digression started because of the main returning value, right? I'm so sorry. Okay, you guys should yeah, you should just draw me in. Okay, so just tell me, let's get back to this code. I would rather have been working on this code. Okay, so let's put a pointer to node star next. Oh, private intent, did it compile? We never compiled it. We didn't compile it. Yeah. Access compile it. If it compiles, then let's that did compile. So go to main and access main. Yeah, node dot data equals 10. Node dot underscore data equals 10. Yeah. Does that compile? That should not compile, right?
It says it's a private data method.
That's funny, isn't it? So it's using struct as a. I got to look, or you got to look. You can share this on Reddit, right? It's strange because struct allows you to have private. So basically, it's starting out. If you have class, I think you have a default private, and then you can say non-default public. But I think struct is basically the opposite, right? You can have the default in struct is public. Everything in a struct is public. Otherwise, it's the same as class. And then a non-default is you can still have private inside of struct. That's the default in. That's what it looks like to me.
It's weird. Yeah.
All right. Okay. Great. So in fact, let's not use private and public. We'll just use what you wanted to do first, right? We'll just do public data, and then node pointer, node star next. Okay, all right, great. I think that's it, right? So in our main, we can say node p, node p, because it's not a node star node p, No, what you had before in the struct node, star node P is fine. I think that's, yeah. Yeah, this nomenclature thing I have to, node P, node pointer, node P. So this nomenclature thing I have to get, maybe I have to look it up, because in struct node, is that node the tag that we use later on, like class, or then, yeah, yes, that's right. So you can actually just say node star, node star. That should also work. Node. All right, so is everybody okay with that? Okay, now on the same line, we can actually say new node. Let's just say equals new node. Is everybody okay? Fernando, welcome to class. Fernando? Okay, all right. Watch the video and get back to me when you watch this line, okay? This part of the video. All right. Is everybody okay with this so far? All right. So on the next line, let's just go ahead and start a for loop. And we'll do a blank line and then we'll do a for loop. I think we can do blank line and then we'll do a for loop. And let's say we create a chain of well, let's create a chain of 10 increasing. No, let's create a chain of 10. Yeah, 10, and then we can merge it to. Yeah, okay. All right, good. All right, let's call that instead of node P, let's call it node star first chain P, right? Or chain 1P or something like that. You know, you come up with a name. I don't know. Hey, I'll leave the hard part of programming to you. All right. So come up with a name. It's got to say first. Yeah. Okay. And then you can also have second, because we want to do two of them, and then we want to do the merge of the two, right? So do a second exactly like that. Well, you know, if I was typing, I would do exactly the same thing. I probably do not such a nice job as Alexandria. All right. So thank you, Alex, for doing this. Okay. Because if I was typing, I was pretty much be doing the same thing. You know. Thank you. All right. Okay. So now what we want to do is first chain P. Set the data of the first chain P item to some, I don't know, some value.
Is it dot or it's this?
Oh, I see. You got pointers now, right? It's arrow.
Yeah.
Yeah. All right. So if you have a pointer, you have to use an arrow. If it's an object, you have to use a dot. So you know, some people, strangely, I have. You know, tell me, you have to encounter both kinds of people, right, in your life. Then you can say, as a programmer, I've lived, right? I've seen both kinds. You shouldn't say, because you know, as a programmer, I've seen people who say, when they encounter a different breed of programmers who do things a different way, they say, no, you shouldn't do it that way, you should do it this way. But yeah, okay. But other programmers will basically say, you know, now I've seen two different kinds of programmers. So you can basically say, I've been programming so long, I've seen like 15 different kinds of programmers. So rather than correct them and say everybody should do this way, you can say how you. So what was I going with that? Node star next week. Actually, I was going somewhere with that and I completely forgot. First chain P, it'll come back to me, obviously, right? Oh, you want to, yeah, all right, great. Rand percent 100. Let's do the second one also. Oh, I see. Let's do, oh, no, wait a sec. Oh, you want to set the data. What we want to do really is, before the for loop, okay, this is what we want to do, okay? Before the for loop, say previous equals 0. The previous 1 equals 0, previous 2 equals 0. So just say previous 1 equals previous 2 equals, or just say int previous 1 equals rand, int previous 2 equals rand. So we're just going to say two random numbers for previous 1 and previous 2. All right, we got two different random numbers. Yes or no? Okay. All right. Okay. Now here, what we'll do here, no, we can leave that there. We'll leave the also rand plus. What did you do before? Rand percent 100. Yeah. Okay. Okay, so what we're doing here is basically, well, I'll explain later. All right, so now what we want to do before you say first char P, first chain P, let's just say previous 1 equals. Now you're going to say within parentheses, you're going to say first chain P arrow data equals. And I'll explain this really weird syntax, right? In fact, what we'll do is after we do the syntax, we'll break it down into multiple segments. And I'll say this is exactly the same as that. And then there's, you can see that how you can condense statements too, right? Okay, arrow data equals previous one plus, no, not equal, not double equals, equals. The previous one plus rand percent 100. All right, so can you reduce the width of the black console, and then we'll get more line. Yeah, that's not much better. Thank you. All right. Yeah, that's great. That's great. All right. Okay. So let's put the same thing in multiple lines. Okay. So go on the next line, and then get rid of the next line, first chain P and all that stuff. Get rid of that, and say put in a comment. We'll say we're going to do the same thing as above in multiple lines, just so it's clear what's going on. Okay. So put a comment. Because why I'm doing this is a common idiom, right? As programmers, we'll be doing this multiple times, millions of times, essentially, right? So you're going to be doing this a lot of times, and so you can save yourself a lot of typing this way, because this is what you're going to be doing. This is a pattern. You're going to just stick it there, and you're done with it. Okay, so you know what's going to happen. All right. So on the next line, let's say what we want to do is we want to say, we got previous one. Now what we want to do is first chain P arrow data equals previous one plus rand percent 100. Yeah. Again, precedence rules and all those things kick in here, and I'm assuming that you're comfortable with this already. Okay, because rand percent 100, it's important to know that rand percent 100 is going to be evaluated before you do the plus, right? Because if you do the plus first and then do the rand percent 100, it basically screws up things. So we want to do the rand percent 100 first, and all those things happen much nicer this way. Okay, so precedence rules, I'm assuming we are comfortable with. Okay, so all right, good. Now on the next line, you're going to say previous one equals, yeah, okay. So this is what we're doing. So essentially, two lines that basically say what the previous line does, right? So, and you condense these two. And is everybody okay with this? Is everybody okay? So let's do the same thing for the other one also. And in my mind, let's make sure that this actually does what we want it to do. So we want to have a sequence of increasing numbers. They're all random. So it's pre-sorted. So that's a cool thing, right? So we could just stick random numbers and then call sort to put them in increasing order. And that's n log n. And this, but if you don't want a particular sorted list, you just want an increasing list of sorted numbers, this is an easy way to do this. Because it'll give you increasing, and it's all uniformly distributed, right? So the increments are kind of uniform, right? So it'll jump increasing, or well, it's sorted. Meaning it's non-descending, okay? You may have, I make this distinction every time in CS2A. Non-descending is different from increasing, right? Because in non-descending, you can have two numbers that are exactly the same, 0, 0, 5, 7, 7, 2, 7, 7, 25, 25, 25, 25, 27, right? So that's non-descending, but it's still sorted. So increasing means every number needs to be at least one more than the previous number, which we're not doing here, okay? Actually, yeah, increasing by n is exactly the same difficulty, right? All you need to do is basically subtract n from all numbers and then treat it exactly the same as non-decreasing, and then you can add n back to all the numbers. So it'll still be in log, it'll still be the same order of complexity, right? In fact, most algorithms you can just apply and apply just fine. All right, so so let's do the same thing with and you can comment out. You can comment out the code also, just to say. Oh. No, those two lines, right? Those two lines. Oh, and maybe we should fix that first line. Say we'll do instead of this. The same thing can be done in multiple lines for clarity. Yeah, I think that might help the students more. Can also be done in multiple lines. Yeah. Does that make sense? Is that okay with everybody? Let's do the same thing for the second one. Now at the end, we should have two lists, right? Both starting at what is it for the first chain one and P. Now
we didn't assign next yet, did we?
Oh, I'm sorry. Okay. Yeah, do that too. Thanks. All right. So I'll talk you through that also. All right. So next. All right. So you're gonna say what is it? A node. The first chain P arrow next equals new node, and then again let's do that also using the same pattern. So we only have two lines inside the for loop. Okay. So all right. And then do the same, and then on the next line, you say, yeah.
And then do we need current?
No, you say first chain P equals. Oh, I see. Oh, we need another one. You need a current pointer, unless we actually, all right, I'm going to leave this as an exercise. You can do this without a current pointer, okay? Because the for loop technically doesn't need the current pointer. All it needs is to basically create a new one, put it there, and make that the next new one, right? And as soon as the for loop is done, you're done. You have first, okay? So in fact, what we need to do, do you have a for loop? Oh, you still need a one pointer that keeps going through. That's what you mean by current. Okay. In the for loop, you need a cursor that actually moves through the next. Can we do that? Can we actually do? Yeah, there's actually no way to do that unless you actually store the first point. Well, there's only 2 extra variables. What the hell am I thinking about, right? So yeah, put the current there, right? So put current there and say current equals. In fact, right there, you can say node star. Right there, you can say, yeah, okay. First cursor, second cursor. First cursor equals first chain P, second cursor equals, yeah, the first current equals first chain P, second node star, second current equals second chain P. 2 extra variables. Yeah, and I was trying to see if I can avoid those. I think, thinking back on it, not out of trying to economize CPU cycles, but trying to economize the number of characters in the program. Okay. All right. So you got to say, yeah, first, what is it? First current equals the next guy. Yeah. And then you can combine it. You can combine it, right? You can combine it just like the previous thing.
Can?
Yeah, just like the previous one. So you can say on line 28, you can say first current equals first current equals. No, just on the first on line 28 at the beginning of line 28, at the beginning of line 28, just say first current equals, and that's it. Okay, and then you can put the whole thing within parentheses just to make it clear. Not the whole thing, just the assignment within parentheses. And again, the assignment within parentheses. Why does it have new node underlined? Oh, no, it's not underlined. It's not underlined. No, it's underlined. No, it's not underlined. Oh, I saw it's intermittent. Right. So the parentheses are not strictly speaking required, right? Because the precedence of the assignment is before. The assignment goes from this side to that side. But we put the parentheses just to make it clear to the reader. Okay, just to improve readability, not strictly speaking, not necessarily. You can look it up. You can look it up. Okay, same as above, same thing as above. We're doing the same thing as above, taking 2 assignments and combining 2 assignments into a single assignment. Same as above, combining 2 assignments into a single assignment. Combining multiple assignments, right? Combining multiple. Does that make sense? Okay, cool. So now we'll have a couple of to-do items that you can do, and I won't walk you through it. And very quickly, in fact, you have to just do a for loop outside of the for loop that prints out the first list, another for loop that prints out the second list. You can do it either on the same line, one number, arrow, next number, and then after the last number, right? One thing we forgot to do is that we actually do need a constructor, or when we create a new node, we got to make sure that its next is null.
Oh.
Because we discovered last class, I think we discovered that C++ doesn't initialize these things for you. Well, let's just do a constructor, a default constructor, very quickly, right on the line. After node star next, just say, yeah, just do a constructor right there. Yeah.
What's the syntax?
Oh, just do a colon. It's not semicolon, colon. Did you have I should move my, no, you have your mouse. I couldn't see your cursor.
Oh.
All right. Okay, colon. And then you say data. You can initialize data right there with a 0 within parentheses. No, not equals, because this is called a chain initialization. It's a new syntax. You can look it up, okay? Just Google it and you can look it up. It's node parentheses, yeah. And then comma, next, parentheses, null pointer. All right. And then you go, no, not semicolon there. You got to tell the compiler, that's my constructor, no more, nothing left to do. And you put empty body within braces right there. There you go. Okay.
Oh.
Technically, you can actually also have logic within that, right? But programmers don't do that. Programmers say that's my really simple struct, especially not for structs. Okay. If you're doing a struct, that's the best constructor to have, because as soon as a programmer looks at that, they know that's what they're trying to do. All right. So now that guarantees that the very first node, which eventually will become the very last node, will have a null child. Okay. So when you hit the null child, you can print a new line and exit. Until then, you can keep printing arrows. Does that make sense?
Mm-hmm.
Okay, so do 2 for loops by yourself, at 10 minutes of your own time, right? You and the rest of you guys talk. And in fact, you shouldn't type, okay? You and Hiram and Lay should try and I know Madison, Agnes, and Fernando, you should try and pipe up, okay? Tell them what to type. 2 for loops, and each for loop should basically print out, the first one should print out the contents of the first list, saying, all right, and after that, you have a to-do saying, I don't know, node star chain 3 equals merge chain 1 and chain 2. And then do another for loop, printing out chain 3. And that should also be in sorted order. Does that make sense? Okay, we're talking about less than about 10 or 15 lines of code all together, okay, including the for loops and everything. 10 to 15 lines of code, but it'll be juicy and fun writing, okay? So how about this? Okay, rather than me talk you through the rest of the code, or me coding also, which is even worse, okay? Alexandria will kindly offer, taking the liberty, okay, of offering to type if one of you will basically call out the code like I have been coding, okay? And obviously other people are also welcome to chime in, right? Maybe if Agnes is going to call out the code and she says, I don't know what to do here, maybe Hiram or Lay, who's done it before, can say, okay, that's what you do here, and or take over, okay? So I want this to be a group effort. Can you guys code up the rest of it? Because that's all we have to do, right? We have to print out the 2 lists, write a little merge function, which will take 2 lists, merge them, and return a pointer to the merge guy. In fact, you can reuse the same nodes. You can take the node from this guy, node from that guy, okay? Arrange them together. In fact, you don't have to do any new or delete even in that merging guy. You just take the beads of this guy and that guy and create 1 necklace out of 2 necklaces given to you. So it's a really cool exercise, isn't it? And you do that in linear time with no memory management other than just shuffling things around. You do that and it returns list 3, which is actually double the length of list 1 and list 2. And then you have the same for loop with the list 3, and it'll print out those guys. And you can see those 2 are mixed in the right order. How is that? It's a really cool project to do, right? For 1 class. Are you guys happy with this?
Mm-hmm.
Okay, I'm going to be around. Okay, I'm going to be here. Anytime you have a question, just yank me back in. Okay, I'm going to be here. I'll be talking. Okay, maybe if Peter's here, maybe I'll give him an acorn or something. Okay, but I'm just going to be here. Okay, maybe I'll just turn it around so I'm not cramping your style. Okay, is that okay with you guys? Raise your hand or thumbs up. Good. Okay, thanks. And by the way, okay, this is the last class of this quarter. If you guys want a class next quarter, anytime before the final or even after, just let me know. Okay, if you have questions about the final, that's fine. Hopefully. You'll get it. It's not a one-on-one. Okay, you don't get a one leg up over. No, but none of you is like that. But I don't answer questions about the final on a one-on-one basis. Okay, so just get a bunch together. Let's put it, make it common for everybody. And I'm happy to talk. You guys have been fantastic. Okay, every class, every quarter, I'm hoping I get a bunch of interested, jazzed up students. And so far, fortunately, I've been lucky, right? Every quarter, I have a bunch of students who stick around like you, right? Interested in CS and these puzzles. And so thank you all so much, okay? Thank you all so much for being part of the course. And I really, really hope that I will continue to see you guys all the way through. Even if it's not, consecutive quarters, maybe you do 2A, take a couple of quarters off, come back and do 2B. I'll still remember you, like Agnes, right? So do 2A, 2B, 2C with me, okay? So I remember you. It's always fun to do it with the same quarter. So if you did it with Dave, it's good to do the same, professor all the way through, because they also get a feel for you, right? Because they know, oh, that student has this particular learning style. So all right. So I know if Madison is in my class next quarter. I know even in the first stand-up meetings, I know that she's not going to have her camera on, right? She's going to reach out in a different way, so we don't have to waste time. Learning styles we can adapt, right? I know that, oh, if Fernando needs, written material for this, I need to send it to. So all of those things I know instead of having to waste time trying to discover. So pick up, just like a language, just like a field, just like everything else, pick something like this and stick with that, whether it's a professor or a subject or a course or something, but your heart, right? Just pick your, whatever your heart dictates, that's your passion, right? And I know it's very trite, right? Everybody from Shakespeare to Sting. In fact, I was guiding another student through past student, not current student, through some code yesterday. And I was just asking for general advice. And so, I guess the best thing you seem to be passionate about all the right things, right? You're interested in all and the thing is to be yourself, follow your heart, despite what other people tell you, right? When other people tell you what you're doing is no good, you should be doing something else, which gives you more money. Don't listen to them, because this is where your passion is. And you're doing good stuff here, but you do mediocre stuff there for more money, right? What's the point of doing mediocre stuff for more money if you can do good stuff for less money? Right? So I said, be yourself. But the thing is, it's very trite. And I realized at that point that, it's very easy advice to give. Right? Everybody says, be yourself, right? Everybody from Shakespeare, Sting, right? Be yourself, no matter what they say. Everybody says, be yourself, Taylor Swift. And it's easy for people to say, I realized, after a certain point, because you cannot, who has the freedom? Everybody who in their right minds doesn't want to be themselves. Everybody wants to be themselves, right? Everybody wants to be free. Everybody wants to do their own shit. Right? Everybody doesn't want, so all of this, everybody wants to be themselves. So, go and tell someone, be yourself. This is like stupid advice, right? So the reason they're not being themselves is because they're not able to. That's the only reason why people are not able to be. Why aren't they able to be themselves, right? Because they haven't yet secured their future, right? So if you guide themselves, someone to say, right, because there are lots of people who've, done incredible things, they've gone to the moon, anywhere, right? So they conquered in the planets too, right? But still, they may not be able to be themselves. They have to watch everything they say, right? They can't. So, so if you decide on what is going to secure your future, saying that's all I need, okay, to live a comfortable life until the end and make sure that I spread happiness until my very last breath, okay, you decide that's all I need and make sure you secure that in some way. And then you can say that's the end of the race for me, right? Then from that point on, you can actually be free to be yourself. Right? Until then, you cannot be yourself, if you think about it, right? So that's why I've decided from now on, I'm not going to tell people to be yourself, right? That's, people say, why am I so, I'm in difficult times. Yeah, you're having a hard time because you're not being yourself, right? And that's so trite. Obviously, that's, everybody knows that. Right. So I think the more sensible advice, which I'm giving you now, is to just pick one of these subjects and commit yourself to it, not with a view of conquering the world, right? If you do it with a conquering, then the race never ends and you'll forever be unhappy, right? So set yourself a goal, right? A specific goal to say, that's what I need until my very last breath in this world. Secure that. Beyond all doubt, obviously things can happen, right? A comet can hit the earth, or you can be kidnapped by terrorists. But those are things that everybody has to face. But secure your once you secure your future, don't keep burning yourself. Winning an endless race. Right? At that point, you can be happy because then you can be yourself. That's all I have. So just commit yourself. And I hope that most of you will come back to my course, right? Do my 2B, 2C, and then go on to do, greater things. And then you can, like I was telling some of these guys, in the future, in the meta universes, you can actually link to this YouTube video, right? On Jupiter or something, saying, back in the day, that was me coding on a measly old, replete. Okay. All right. So that'll be cool. Or someone will do that, right? Even if not you, maybe someone will do that. Okay. That's our CEO or our president, Okay. All right. Have a great time. Best of luck for your exams. Feel free to yank me back into the conversation either today or any other time, right? And I really do wish you the best, okay? Even if I don't see you again, right? I do hope I see you all again and again, okay? So best of luck. All right, I'll see you guys later, right? And email me, I'm reachable, okay? I'm gonna, turn around. I'm just gonna be around until the end of class. When I hear silence, I'll come back and switch it off, right? And put it on YouTube. But until then, feel free to talk and code. If you have any questions, call me, I'll be around, but I'm not gonna be watching, okay? All right. Thank you, guys. It's been a fantastic class. Wonderful. Bye-bye.
Bye.
Thank you.
Bye. No worries.
Okay. Can we start with the sorting since and then we can do the printing because the printing is easy. Guys?
Yeah, sorry, what was that?
Oh, can we do the sorted first and then the printing?
Sure.
Okay, all right, you guys guide me. I kind of know how to do this, so.
Frankly speaking, I have no idea how to do this, so I'm looking it up, but
Yeah, so while he was talking, I just
can you
made it like,
scroll up a little bit? Sorry.
Oh, sure. Here, this is what we got.
Right, so far. Okay.
Hiram, what were you saying?
while he was talking, I went and hand coded the entire OT of Quest 9 using the no header format, and it
Oh,
still
that's
works.
awesome.
I just rewrote the entire thing. So,
So you're ready for the fight.
oh, I already did 9. So
Yeah,
I
you're good.
have done this. I think I'm good. Yeah.
Okay.
So I'll try to set out like you.
For this one, it's kind of like we have to go like node by node and compare, and then we make a new chain. And like if one is less, then we attach it to the new chain, and then increment a current pointer, and then compare again. So you just keep going down the 2 lines, building this new chain. Does that make sense?
Yeah, I think so. So let's say the first chain is 1, 2, 3. Second chain is 4, 5, 6. Then this program would make a new chain 1, 2, 3, 4, 5, 6.
Yes.
And then if the first chain was 1, 2, 6, the next chain was 3, 4, 5. It'd still give 1, 2, 3, 4, 5, 6.
Yes, exactly.
Okay.
That's tough.
Okay, I'm gonna let you guys guide me on the code, but that's kind of what I had in mind. A new chain, 2 current pointers, and comparing data. Or 3 current pointers. Yeah. 1 for each chain of the 3 chains.
And are we working on initializing first the 2 chains first?
Wait, was the
Oh.
requirement that both chains were sorted already?
Yeah, they're already
Okay,
sorted.
then I know how to do it. Okay.
Okay, great. So yes, Wesley, we can make a new first,
Let me make that actually.
but
And did,
it will be. We'll need a third. And we have to assign the first outside of a loop, I think. So, the first change fee data less than second chain fee data. Then we do third chain equals first chain fee. Make sense? So second fee, and we have a third current third chain fee. Okay, and now I'll stop taking over because I'm doing too much. Okay, does that make sense?
yeah.
Okay, cool. Can you guys guide me through going over the 2 chains?
Are you talking about the ones above to do for loop that prints out the first chain?
We can do the printing first if you guys want. Sure.
Oh, okay. Right. So So I guess you would definitely need some sort of loop.
Okay.
Are both chains always going to be the same length?
Yeah, they're always 10. We could start with that for you.
Okay, yeah, so it'll have to look at 20, yeah, 20 at least, or no, just 20 nodes, right?
Well, we're printing out one list at a time. So can we do?
Oh, we're doing that. Oh, yeah, then it's 10, yeah. And then you just print, is there a date?
Oh, right, Kurt.
So, first,
We need that current again. So current will first chain be.
yeah,
So we start there.
yeah. Then, yeah, the data. thing.
First current data, and then
Advance,
envelope.
yeah,
And
and then
then,
advance the, yeah.
okay, cool. We could probably do like a while first current's not a null pointer.
But we know it's 10. I mean, you could do that.
Okay, let's keep it then, and then we'll do the same thing with second. We don't have to. Okay, let's see if it works. Oh my God, what happened? Is it this?
26.
Why would it print
No, it
out
should be
726 and then 0? Oh, something is very wrong.
Maybe
Okay.
something with creating the list. as
Yeah,
well.
it has to be creating, right? Do you think it's the uh-oh.
Yeah.
Guys, we need more people on this. You
Wait,
think
what?
it's the what?
What are we doing?
You think we're just trying to print out the list and we're getting a segmentation rule.
Oh no. Wait, what the heck?
This is not good.
Yeah, that's really
I'm
not good. I
pretty
really
sure-
like using the while loops though. They help a lot.
I'll
Okay,
switch it to
so-
this just so, because then we'll know if we're getting a null pointer.
Yeah.
Yeah, we're not building the list right. You're totally right, Wesley. Like, we're not building it right.
While.
Oh,
Yeah, it's wrong.
Dude, just do it.
I bet it's the double assignments, because when he was saying that, I was like, I don't know, in Java this wouldn't work. But in Java, when you do an assignment, it returns true or something like that. I don't know. This is weird.
What's previous one here?
Oh, previous one is just some random number,
Okay,
and we assign it to data
I know.
right here, where we're supposed
okay.
to. Can we put some couts in here? Okay, so it's going through 10 times. It's just not
Yeah.
building the list.
Uh,
Oh, all right. Let me try this. Let's see if it's the assignment thing. Oh no. Do I really have to do this?
Use the size.
why are you resetting the head pointer over and over?
Oh, where?
Because I don't understand why there's 2 equal sign in line 20.
Oh, that? Yeah, I have a feeling this is wrong. Like, it just feels wrong. But
But You're saying first chain P data is equal to previous one, whatever. And
Yes,
first chain P is never being advanced.
first chain,
So
right.
you're resetting the head pointer over and over. Is that right?
Nice. Let's do this. So you're thinking it's first current and second current. Yeah,
But
that's
you're
a
not
good one.
advancing first current or second current either.
We are down here. We're
Oh,
supposed
that is?
that was definitely a bug you found, but
Okay, right, I think maybe we should, if no one understands what this does, really, we should just get rid of it and make
Wait,
it in the way we
those two
understand.
lines that say first current equals first chain P next not equals new node. That?
yeah, I have a feeling this is wrong.
I don't think so. That seems right to me because all it's doing is saying that the first current is equal to the thing at the next position, which will be a new node.
So in C++,
Problem could
it-
be that the next is a null pointer. I don't know if that would make any sense though. No, that doesn't make sense. Okay.
oh,
So new node would make a new node and then the next would point to it and then we're moving to it as long as it's first current, not first chain P and second chain P. Should be first current and second current in there.
oh, it should be this. Oh, that was it. It was my bad. It was the exact same bug Wesley found, but the opposite.
I don't know.
Oh,
That worked.
all right, now we're good. Except for
Oh,
the
there you
zero
are.
at the end.
That's probably because of a messed up condition somewhere.
I think it's because
Probably in
we're
your
making
CS
a
statements.
we're making a new node.
Oh, that's a
after.
good point. That's a good point. Yeah, that's something that I had to work to avoid in my quest.
Okay, we'll just fix the last zero. Not a big deal.
Uh,
Okay,
I'm trying to find the silly condition. Oh, wait, so
okay, this one is annoying. So we have 2 pointers. First current is gonna start by pointing to. And I think we need to do this. First current equals first thing next. I don't like this at all. This is so dirty. You see what I'm doing though, right?
Shouldn't it be first? Hold on. Okay.
yeah, that's what I'm trying to figure out how to do elegantly too.
This is cringy.
Yeah, I'm thinking of what I'm trying to do is make a while loop, right? So that I can rewind from the beginning and then while it's true, while I don't know what the while condition is yet, I'm trying to figure it out, but every time that it goes through the while loop, it'll choose which one's bigger, right? Set the new lists, push the smaller one,
Yeah,
push the smaller one onto the new list, right? Using like push back method that I made. And then it can advance the current of the list that it just took it from. And
Yes.
then once both of them get to the end, it'll be done. But I don't know how to make the while condition
I think
because
it would be while one of them is not a null pointer. You'll have to keep attaching.
that's true. But the problem is that I can't check the other one being a null pointer because it's being passed in by reference. So it's a private number.
Oh,
So I can only check one of them. Yeah, you can totally do that, but I have to figure it out. It's
Ours
different.
will be okay, I think.
I mean, I could just make a new method that says check if it's at the end. Right, like
That's
check
true.
tail. That would probably be a good method to have anyways. Yeah, I could do that. Let's just do that. I have, wait, what do I have?
Okay, well, I did all that setup up here. Wesley, so that we have our currents. And oh, it's so bad though. And I've got to go. But one of us should finish this and then post it to Reddit.
I definitely can't
Just
post
choose-
mine.
Oh, because it's like quest 9.
It's exactly quest 9.
Oh.
Not really. Wait, Quest 9 only has one linked list.
Yeah, but it makes an entire class, so I can just make multiple if I want to. The heck? That's my, oh, right. I have my method now. Mile.
All right. Yeah, I've got to go. It was good being in class with you guys.
Or
Yeah. Good luck on the final, guys.
not. No, not list. Tail. Is that a good version? What? You. What should it be? Oh, I need them. Oh gosh. I've been into another situation.
Are you working on are you on Replit?
Oh no, not at all.
No.
Okay. Yeah, I'm on my editor
Yeah, that's okay.
because I can't be doing nearly quest stuff on the Replit.
Oh, okay.
If you want help though, I can stop. I mean,
It's up to you, man.
okay. Oh, that's so stupid. Why did I not think of that?
Say you finished Quest 9 though? That's
Yeah,
all
yeah.
the quests you need.
Yeah. I mean, I have 180 of the points, so I'm done with the quests. But I don't have like more than that. I could get more, but I don't really want to work towards it. I have
So
exactly
it's
what I
extra
need.
credit?
Sort of. I don't really know. I just know that it's capped at 195, but he says that 180 scales to 60% of the grade.
Okay.
Merged equal. Oh wait, no. Merged. Oh wait. If current less than list.
Segmentation fault. Okay.
Merge equals merged current. I need to create a blend plus merged current. I need to advance. Oops. Okay. And This feels wrong. Let's 60D. Let's go. And to add equals. Okay, I can do condition current. Current question mark. Current. Yes. Okay. And then linked list merged equals. No, not equals, to add. Okay, and then all I need to do is repeat that. Oh shoot, that is something I need to do. It's not much better than oops, let's do that. If current plus list linked list merged current and evidence else linked list merged list current evidence no list evidence.
All right, I can't really figure out what's going on with
Okay.
it. I'll just randomly post it on Reddit.
Oh, okay.
Yeah, and I have to go. All right. See you.
Okay.
Good luck on the
Bye.
file.
Bye.
Hey guys, I heard silence, so I came back, but it is the end of time, so I appreciate many of you would have gone. Everything okay? Did you guys manage to make some interesting headway today?
I don't really know.
No?
I was doing something else, but
Oh,
related.
you are, but it is on video, I hope, but you can watch the video, right?
Yeah, I was
But
going.
do you have any
I
questions?
was. Not well. Besides quest for the precision error, I still haven't figured it out because even when I figured out how to set the precision, the one that it wants is like different per thing. So I think I'm just calculating it differently than you are, and I don't know how to fix that.
Try sprintf, right? Or printf or
Sprintf.
sprintf or printf.
Is
Just look
that
up the manual. It'll let you
okay?
print according to specific precision. It's a long time I've forgotten quest 4, but I don't think that I am, unless I actually said something about sprintf. No, I'm just using cout.
Yeah, I figured you weren't using anything that complicated. So I think what's going on is that I'm just calculating the GPU terms
Yeah,
differently, and
it's the
that's
order.
making everything wrong.
Yeah, the order in which it's being calculated is probably
The
different.
order?
Well, I think one way to debug this is basically write it out on a piece of paper, the series, right? And then see how many different ways you can do this. Do I do the plus before the times and things like that? And then some pattern will begin, and then you'll say this, oh, 2 different ways I can do this, right? I can either do all of the pluses together or all things. You'll see it's not like there's not like an infinite number of ways in which you can do it. There's only like 1 or 2 different ways. Once you write it out on a piece of paper, and in your mind, when you say, this is how I'm going to calculate it, there's only 1 or 2 different ways you can figure out, right? And one of those is what I'm using.
I see.
Not the other one.
I guess that makes sense. I'll have to figure out what other ways there are. I didn't want, because I was doing it trying to like avoid too much calculation.
Yeah. No, that's
right?
fine. That's right.
But
I
think that
it is good to avoid too much calculation. Maybe the initial value is different, or maybe the order in which things are being added is slightly different.
It's the GP terms, not AP. So it's multiplication.
No, but you still, it's just terms, not the sum of the terms. Okay. All right. So just the terms. Yeah. Maybe the order in which things are being multiplied is different.
Yeah, because I have like an ongoing term that I then multiply by thing every time the loop goes around. So,
See, but fortunately, when you're trying to debug this with A, B, C, D, E, A times B times C times D times E, there's so many different combinations in which you can get that product. But fortunately, we don't have to look at all of them, right? Because we know we either did A times B, B times C times, we did it in this order, or we did it in the other order. I don't think we would have done these messy other orders, right? A times B times C times C times C, right? So many different orders, so many different permutations. We don't have consider all of those. But each one will produce a different result. Every pair of numbers you choose to multiply potentially gives you a different result.
yep.
Right? Because the overflow is different in every single case, right?
Indeed.
Yeah, because the numbers we're talking about are not have a precision that is beyond what can be stored even in double precision arithmetic.
Yeah, definitely.
Yeah. You may have to go right now, but I think that's what it is. If you just look at the order in which things are being calculated, you'll find the solution.
Okay, I'll try to go find that.
Thank you for being part of the class, Hiram. You've been very instrumental in driving a lot of this section. So thank you also to Alexandria and others who have been regulars. All right. I hope you guys got something useful out of this class.
Yep.
All right. I'll see you in a future class.
See you in future class. Bye.
Bye.